Hello everyone, this is Sai Sri and welcome back to my channel. Before jumping into the video, make sure that your quality resolution is about 720 pixels or 1080 pixels so that you can clearly see all the components and the text in the Multisim software. So let's start the video. In this video, we are going to see the simulation of the current series with feedback and without feedback using Multisim software, and we will also see the frequency responses and how to take the values in the graph sheet. At the end of this video, I will show you the manual of current series with feedback and without feedback. So let's jump into the video. Firstly, I will place all the components required for the current series with feedback. So in order to place the components, just click on place and then components and then search for the component you require and then click on OK. Drag that component and place it on the sheet or the breadboard as shown. So these are the components required for the current series with feedback. So if you want to change the value, just click on the component, then a window will be opened so that you can change the value of the resistor or the VCC, whatever you want. Now it's time to connect the components. So be careful while connecting the components. Check the nodes in which you are connecting. If not, you are not going to get the output. So follow the video while connecting the components. I want to differentiate the input and the output, so I have changed the color of the output to the blue. So in order to change that, just click on the wire of the output wire which you have connected to the oscilloscope, and then a window will be open. There you can select the color you want and then click on OK. So in order to simulate the circuit which we have designed, just click on the run button which is in triangle shape. So click on the oscilloscope to see the output. Adjust the channel A and the channel B scales so that you can get the output. So as it is an amplifier, it is going to strengthen the given input. So red color represents the input and the blue color represents the output. So the amplitude of the output is increased because of this current series with feedback amplifier. So it is the circuit diagram and the output in the oscilloscope. In order to get the frequency response, so follow the steps: simulate, analyze and simulate, AC sweep. So now here we have to select the frequency range. I am selecting 1 to 10 MHz. So based on your requirement you can select it. So the output is the voltage at the oscilloscope. So the wire which you have connected to the oscilloscope, that is in blue color, just click on it, then you can get the net value. So select that voltage at the output. So here I got VA. So I am selecting and then clicking on run button. So this is the frequency response of the current series with feedback amplifier. Frequency in the x-axis and the magnitude in the y-axis. So below graph represent the phase. You can move the cursors to get the values at the different parts of the graph as shown. So by clicking on these cursors you can get the bandwidth. So first cursor will give you the frequency 1 cutoff frequency and the other one will give you the upper cutoff frequency. And to get the values, just click on tools. So a graph sheet will be displayed, Excel sheet. So here you can get the values, all the frequency and the magnitude values. So take some of the values which you required for your experiment. Take the constant values so that they represent the bandwidth of your current series with feedback amplifier. So the same procedure we have to follow for the current series without feedback amplifier. So for this we have to place an extra capacitor to the emitter of the transistor. Just I am copying the same circuit. So I have copied the same circuit. Now I am going to place a capacitor here. Now run the circuit and click on the oscilloscope to see the output. So this is current series without feedback. In without feedback amplifier we are going to get the more gain than the with feedback amplifier. So the same steps we have to follow for current series without feedback amplifier also. So the blue one represents the output and the red color represents the input. You can adjust the scales of the channel A and the channel B to get the output you required. So for the same scale, the output is very large, so it is amplified. So this is the frequency response of the current series without feedback amplifier. The gain is more for the without feedback amplifier. By moving the cursors, so just click on cursors, you will get two cursors. Just move the cursors to get the upper cutoff frequency and the lower cutoff frequency for the current series without feedback amplifier. So by taking these two frequencies, just subtract upper cutoff frequency minus lower cutoff frequency, you can get the bandwidth. So to get the Excel sheet of the values, just click on tools and then click on OK. So a sheet will be displayed at the bottom of your system. So this is the Excel sheet. Click on it. So these are the values for the current series without feedback amplifier. So you can take the values which you require for your experiment. So now let us see the manual of the current series with feedback and without feedback amplifier. So this is the aim, and the software we used is NI Multisim software, and the components are shown in the table. So these are the circuits which we have designed. Current series with feedback, and the below one represents the current series without feedback amplifier. So this is all about the current series with feedback and without feedback amplifier simulation. If you have any doubts in simulation process, please do comment in the comment box. Also watch the other videos of the multisensing. I will try to drop all those links in the description and the comment box of the other multisim experiments. Thanks for watching.